That rock was almost thrown away. Dark volcanic stone suddenly glowing bright blue under sunlight. A cracked piece of mud revealing moving fire inside. A dull gray rock exploding with electric color the moment it turned. None of them looked valuable at first. That's what makes these discoveries so unsettling. Some of the rarest gemstones on Earth stayed hidden for millions of years inside rocks miners ignored, stepped over, or nearly discarded completely. A few were so deceptive that even experts failed to recognize what they were holding. And one of them looked so ordinary that nobody bothered picking it up until light exposed something impossible beneath the surface. Starting with a dusty stone hiding fire no one expected to find. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Sunstone, the rock nobody wanted. Most people would never stop to pick up a rock like this. Its surface looked dry, dusty, and strangely dull beneath the desert sunlight. No sharp crystal edges, no deep color, no obvious beauty. Just another rough piece of mineral debris scattered across remote volcanic terrain in the American Northwest. The kind of stone collectors usually ignore without hesitation. For years, rocks like these were pushed aside during excavation work because they appeared too ordinary to contain anything valuable. Some were tossed into buckets with common feldspar fragments. Others sat forgotten near old mining roads, blending perfectly into the surrounding earth. Nothing about them suggested rarity. That illusion is exactly what made the discovery so fascinating, because hidden inside certain rough sunstone specimens was an optical effect so unusual that early miners reportedly mistook it for trapped metal particles. Under the correct angle of light, tiny copper inclusions buried within the stone suddenly ignited into flashes of gold, red, and fiery orange shimmer. Not polished sparkle, not surface reflection. The light seemed to float inside the stone itself, and the contrast was startling. Moments earlier, the rock looked completely worthless, faded, cracked, almost lifeless beneath layers of dust. Then, a slight turn beneath sunlight transformed it into something that appeared almost molten from within. Gemologists later identified the phenomenon as aventurescence, a rare optical effect caused by microscopic copper platelets suspended naturally inside the crystal structure. In exceptional specimens, the internal flashes become so intense that the stone appears illuminated beneath the surface, especially during sunset or direct outdoor light. But before cutting and polishing, many sunstones still resemble ordinary volcanic rock. That is what continues to attract experienced collectors. The discovery feels personal, not manufactured, not obvious, not handed over immediately. The beauty has to be uncovered slowly. And unlike diamonds or sapphires displayed behind bright jewelry glass, rough sunstone discoveries often begin in silence. Inside dusty terrain where nothing appears valuable at all. That hidden quality gives the gemstone a completely different emotional atmosphere. The stone does not announce itself aggressively. It waits, which raises an uncomfortable possibility. How many extraordinary gemstones have already been discarded simply because nobody looked closely enough? In some mining regions, workers later admitted that unusual stones had likely been thrown away for years before anyone understood what they actually contained. And one of the next discoveries became even harder to believe, because the gemstone hidden inside the rock was so rare. Many miners initially thought the blue crystal forming in the volcanic stone had to be artificial. Ranked 9th, Benitoite, the blue crystal hidden in volcanic stone. At first glance, the stone looked harsh enough to damage tools. Dark, dense, jagged along the edges. The kind of volcanic rock most miners break apart quickly without expecting anything valuable inside. Across remote regions of California's rugged interior, formations like these have existed for millions of years. Hardened remains of violent geological pressure, buried beneath dry hills and fractured serpentinite. Nothing about the landscape feels luxurious, and nothing about the rock itself suggests rarity. That is part of what made the discovery so shocking, because hidden inside certain pieces of this rough, volcanic stone were small blue crystals, unlike almost anything else found on Earth. Their color appeared strangely electric beneath sunlight, deeper than sapphire in some angles, brighter than ice in others. Under direct light, the crystals produced flashes so intense that early miners reportedly questioned whether the material could even be natural. Some assumed it was glass. Others believed it had to be synthetic contamination mixed into the rock somehow. But the crystals were real, and they belonged to one of the rarest gemstones ever discovered in the United States, Benitoite. What makes Benitoite especially fascinating is how completely invisible it remains before extraction. The surrounding host rock often appears heavy, dull, and worthless, giving almost no indication that delicate blue crystal formations are trapped inside. Even experienced workers sometimes overlook specimens entirely because the gemstone rarely reveals itself clearly until the rock is broken at exactly the right angle. That hidden nature transformed Benitoite into something almost legendary among mineral collectors. Not because the gemstone is enormous, because finding it feels nearly impossible. Geologists later discovered that Benitoite formed under an extremely narrow set of volcanic and hydrothermal conditions unlikely to repeat in many places around the world. In fact, high-quality specimens remain so rare that some collectors spend years searching for examples with strong color and clean crystal structure. Yet before discovery, many of those same specimens looked no different from ordinary volcanic debris scattered across remote terrain. That contrast continues to define the gemstone's appeal. The exterior feels brutal, unwelcoming, almost lifeless. Then, suddenly, beneath fractured stone and mineral dust, impossible blue light appears where nobody expects it. And discoveries like that tend to change the way collectors look at ordinary rocks forever. Because once nature hides something extraordinary successfully enough, people begin wondering how many other treasures remain buried inside stones nobody bothers examining closely. And the next gemstone created an even stranger problem. Miners actually saw the stone repeatedly, but failed to recognize what was hidden inside until light exposed a perfect star across its surface. Ranked 8th, star sapphire, the dark rock miners ignored. The stone did not look valuable. Its surface appeared dark, cloudy, and strangely lifeless beneath layers of dust and mineral residue. Compared to transparent sapphires prized in jewelry stores, rough star sapphire specimens often seem disappointing at first glance. Dull chunks of corundum, lacking the bright sparkle most miners search for immediately. That is exactly why so many were ignored. In mining regions across parts of Asia and Sri Lanka, rough sapphire-bearing stones have passed through countless hands over the years. Workers searching quickly through excavation debris often focused on visible clarity, vivid transparency, or strong color flashes. Stones that looked too opaque or overly dark were frequently pushed aside without much attention, and some of those rejected rocks contained something extraordinary. Because hidden beneath the rough exterior of certain star sapphires lies one of the rarest optical effects found in natural gemstones. Under direct light, delicate needle-like inclusions inside the stone align with such precision that a glowing six-rayed star suddenly appears across the surface, not painted, not carved, naturally formed inside the crystal itself. The effect can feel almost unsettling the first time it appears. A rough stone that moments earlier looked worthless suddenly produces a sharp floating star that moves slowly beneath light as the gem rotates. In exceptional specimens, the star appears bright enough to look artificial, especially against deep blue or smoky black surfaces. That transformation changed the way many miners viewed rough sapphire material forever. Because the most valuable star sapphire specimens rarely announce themselves clearly in raw form. The gemstone often hides its optical structure beneath cloudy layers that reveal almost nothing until the surface is properly cut and polished into a smooth dome shape, which means countless rough stones may have been discarded long before anyone realized what they contained. Gemologists later explained the phenomenon as asterism, caused by microscopic rutile inclusions intersecting within the sapphire's internal structure. When aligned correctly beneath focused light, those inclusions reflect a perfect star pattern across the stone's surface, an effect so precise it appears engineered rather than geological. But nature created it entirely on its own. That contradiction continues to fascinate collectors. The exterior feels heavy, dark, almost disappointing. Yet hidden beneath the surface is extraordinary symmetry waiting for the correct angle of light to expose it. And perhaps that is why discoveries like these remain so captivating, because they force an uncomfortable realization. Sometimes the rarest things in nature are ignored, not because people never saw them, but because they looked too ordinary at first glance. And the next discovery became even stranger, because one rare gemstone remained buried underground for centuries, until violent rainstorms unexpectedly exposed flashes of color inside the mud itself. Ranked 7th, Ethiopian Opal, the mud-covered discovery. The discovery began after heavy rain. For days, violent storms moved across the dry volcanic highlands of Ethiopia, cutting through loose earth and flooding narrow pathways between dark rock formations. Entire hillsides softened beneath the pressure of rushing water, exposing layers of mud and fractured stone that had remained buried for centuries. Most of what surfaced looked completely worthless. Broken rock, wet clay, dark mineral debris scattered across the ground. But then, something unusual started appearing beneath the mud, small flashes of color. At first, the effect seemed almost accidental. Tiny bursts of green and orange visible only for a moment before disappearing beneath dirty water and loose sediment. Some locals reportedly assumed the reflections came from wet glass or surface minerals reacting to sunlight after the storm. The reality was far more extraordinary. Hidden inside the rough volcanic material were Ethiopian opals, one of the most visually unpredictable gemstones ever discovered. Unlike traditional gemstones that reveal value through transparency or crystal shape, opals behave differently. Their beauty remains hidden beneath ordinary-looking surfaces until light enters the stone at the correct angle. Then everything changes. Under sunlight, fine Ethiopian opals can erupt into moving color patterns, so intense they appear artificial. Electric green flashes collide with molten orange, deep red, cobalt blue, and shifting spectral fire that seems suspended beneath the surface rather than reflected from it. And before cleaning or cutting, many specimens still resemble nothing more than dirty rocks pulled from wet soil. That contrast transformed the discovery into a geological sensation. Because nature had hidden extraordinary optical structures inside material, most people would never examine twice. In some cases, miners later admitted they initially stepped over exposed opal-bearing stones without realizing what they contained beneath the mud coating. The gemstone itself forms through silica-rich water, slowly filling microscopic spaces within volcanic rock over immense periods of time. As conditions shift underground, layers develop capable of bending light into moving color across the surface, a phenomenon so unstable and complex that no two opals ever display identical patterns. That uniqueness gives Ethiopian opals a strange emotional quality. The stone feels alive, not polished into perfection, not predictable, not controlled, just hidden, waiting for the correct moment, the correct light, and sometimes even the correct storm to finally expose what had been buried beneath the earth all along. And discoveries like these changed the way collectors viewed rough volcanic terrain forever. Because after enough hidden gemstones emerge from worthless-looking rock and mud, ordinary landscapes stop feeling ordinary. But the next stone created a different kind of obsession entirely. Not because of color, because people became desperate to see what was hidden inside before the rock was finally cut open. Ranked 6th, Thunder Egg Agate, the stone nobody opened. At first glance, the rocks looked almost absurdly ordinary, round, dusty, heavy for their size. Some resembled dried clumps of hardened mud more than anything geological worth examining closely. Along dry desert regions in parts of Oregon and the American Southwest, thousands of these strange stone nodules have been scattered across volcanic terrain for centuries. Most people walk past them without a second thought, and for a very long time, miners did the same, because from the outside, thunder eggs reveal absolutely nothing. No crystal flashes, no visible color, no hint that anything unusual exists beneath the rough exterior. Their surfaces often appear cracked, weathered, and uneven, closer to broken concrete than valuable mineral formations. That mystery is exactly what transformed them into collector obsessions later. Because unlike most gemstones that expose small clues on the surface, thunder eggs remain completely sealed. The only way to discover what is inside is to cut them open, and that is where the fascination begins. When diamond saws finally split certain specimens apart, hidden interiors started appearing that seemed impossible compared to the dull rock outside. Swirling agate bands emerged in deep reds, creams, and burnt orange layers wrapped around crystal-filled cavities glittering with quartz formations beneath the surface. Some looked like frozen underground storms. Others resembled tiny geological worlds trapped inside stone. And no two were ever completely identical. That unpredictability became addictive among collectors because every unopened thunder egg carried the possibility of surprise. One rock might contain almost nothing at all. Another could reveal intricate crystal chambers hidden beneath inches of worthless-looking volcanic material. Even experienced rock hunters often cannot predict which specimens contain extraordinary interiors until the moment the blade cuts through the center. That uncertainty creates a strange emotional tension rarely found in gemstones. The value is invisible until destruction begins. The rock has to be opened, broken apart, cut through, revealed. And for many collectors, that process feels almost more exciting than the gemstone itself. Geologists later explained that thunder eggs formed millions of years ago when gas bubbles inside volcanic ash layers slowly filled with silica-rich minerals over immense stretches of time. Layer after layer developed quietly underground, hidden completely from the surface world. Which means some of nature's most intricate mineral structures spent millions of years disguised as worthless rocks nobody bothered examining closely. And perhaps that is what makes them so captivating, because the outside gives no warning whatsoever. Nothing suggests beauty is waiting inside. Until the stone finally opens. And the next discovery became even harder to explain. Because one dull gray rock suddenly erupted with electric blue light the moment it moved beneath the sun. Ranked 5th, Labradorite, the gray stone that suddenly ignited. Nothing about the stone looked impressive at first. Its surface appeared cold, gray, and almost lifeless beneath cloudy daylight. No transparency, no visible crystal structure, no obvious color. In some conditions, Labradorite can resemble broken pavement more than a gemstone. Rough slabs of dull mineral material scattered across rocky terrain in northern regions of Canada and Madagascar. That plain appearance fooled people for centuries, because Labradorite hides its real nature almost completely until light strikes the surface at exactly the right angle. Then the stone seems to ignite. Without warning, electric blue flashes explode beneath the gray exterior. Waves of green, gold, and deep turquoise suddenly move across the surface like shifting light beneath frozen water. Some specimens produce such intense color that the effect appears almost digital, especially against the otherwise dark and lifeless stone surrounding it. The transformation feels unnatural the first time it happens. One moment, the rock looks worthless. The next, it appears illuminated from somewhere deep inside. That phenomenon became known as labradorescence, an optical effect created when microscopic internal layers inside the stone scatter incoming light into brilliant spectral flashes. Unlike gemstones that rely on transparency or sparkle, labradorite behaves more like hidden electricity trapped beneath solid rock. And before polishing, many high-quality specimens reveal absolutely no hint of what they contain. That hidden quality changed how collectors viewed rough stone forever. Because labradorite does not reward quick observation, the gemstone forces patience. A rough specimen may appear completely dead until the exact second sunlight moves across its surface and hidden color erupts beneath the stone like a sudden electrical surge. Some rock hunters describe the experience almost like discovering a secret hidden inside ordinary matter. And perhaps that description is not entirely exaggerated. Geologists later discovered that the gemstone's internal structure bends light through tightly layered mineral formations developed under extraordinary pressure deep beneath the Earth's crust. Tiny structural differences determine whether a specimen remains dull gray forever or suddenly bursts into violent color under movement and light. That unpredictability makes each discovery feel strangely personal. The stone chooses when to reveal itself, not immediately, not clearly, not to everyone. And maybe that is why labradorite continues to fascinate collectors so deeply, because it challenges a powerful assumption people make every day, that valuable things should look valuable instantly. Labradorite refuses to do that. It hides brilliance beneath something ordinary enough to ignore, until the light finally changes. And the next gemstone pushed that illusion even further. Because the stone's color looked so unnaturally intense, many people refused to believe it could possibly have formed inside the earth at all. Ranked fourth, hidden garnet in schist, the crystal buried in broken stone. The rock looked shattered long before anyone considered it valuable. Dark layers of broken schist lay scattered across excavation sites like fractured concrete pulled from deep underground. The material crumbled easily in the hands, leaving behind dusty flakes of compressed mineral debris with almost no visual appeal at all. Most workers ignored it immediately. Because schist rarely looks beautiful. Its surface appears rough, compressed, and unstable, the product of immense geological pressure that twisted ancient rock layers beneath the earth for millions of years. In mining environments, broken schist is often treated as little more than surrounding waste material, hiding around more obvious mineral deposits. But occasionally, the fractures expose something unexpected. Deep inside certain pieces of dark schist, small flashes of red begin appearing between the compressed layers. At first, the color can look almost accidental, tiny reflective surfaces hidden inside cracked stone. Some miners initially mistake the crystals for rust stains or iron contamination trapped within the rock itself. Then the light changes, and suddenly the buried crystal structure becomes visible. Hidden within the worthless-looking schist are garnets formed under extraordinary pressure deep beneath ancient mountain systems. In exceptional specimens, the crystals emerge with rich crimson tones, so dark they resemble frozen drops of wine trapped inside the stone. Others reveal sharp geometric formations embedded directly within the fractured rock matrix itself. The contrast feels almost impossible. Outside, the rock appears damaged, collapsed, broken apart by geological violence. Inside, perfect crystal symmetry survived untouched for millions of years. That contradiction is part of what makes garnet discoveries inside schist so fascinating to collectors and geologists alike. The gemstone does not appear in isolation. It remains locked inside the very pressure system that created it, a mineral preserved within the scars of Earth's most violent transformations. And before extraction, many specimens still resemble worthless excavation debris. That hidden nature caused countless pieces to be discarded long before anyone recognized the crystals buried inside. Geologists later explained that garnets form when extreme heat and pressure reorganize mineral structures deep underground during metamorphic activity. Over immense periods of time, atoms align into stable crystal formations capable of surviving conditions that destroy surrounding material completely. Which means some of the most beautiful crystals on Earth were created inside environments violent enough to crush ordinary stone apart. And perhaps that is why discoveries like these leave such a strong impression. Because they reveal something unexpected, hiding beneath destruction itself. A flawless crystal preserved inside broken rock, waiting for the correct fracture to finally expose what pressure had concealed for millions of years. And the next gemstone discovery became even harder to believe. Because the color hidden inside the volcanic stone looked so unnaturally bright. Many experts initially suspected it could not possibly be natural at all. Ranked third, Oregon Fire Opal in volcanic matrix. The color hidden in ash stone. The rock looked burned long before anyone realized it contained color. Its surface appeared blackened, brittle, and dry beneath layers of volcanic ash and fractured basalt. In certain areas of Oregon's ancient lava fields, pieces of stone like this cover the ground by the thousands. Rough volcanic debris left behind by eruptions so violent they permanently reshaped the surrounding landscape millions of years ago. Most of it appears completely lifeless. That is what made the discovery so difficult to believe. Because hidden inside some of those dead-looking volcanic rocks were sudden flashes of orange so intense they seemed almost liquid beneath the stone's surface. At first, the color only appeared in tiny seams exposed along natural fractures, thin, glowing lines buried inside black volcanic matrix rock. Then, larger sections were opened, and the effect became extraordinary. Inside the worthless-looking stone sat fire opal formations glowing with deep ember orange, molten gold, and translucent red tones that appeared almost suspended within the rock itself. Under sunlight, certain specimens seemed less like gemstones and more like trapped volcanic heat frozen beneath hardened ash. The contrast felt unnatural. Cold black stone on the outside, living fire inside. That contradiction became one of the reasons volcanic opal discoveries fascinated collectors and geologists so deeply. The gemstone looked emotionally connected to the environment that created it, as though ancient eruptions had somehow preserved fragments of molten color beneath the earth instead of destroying them. And before cutting or cleaning, many specimens still resembled ordinary volcanic waste. That hidden nature caused countless pieces to remain unnoticed for years. Because unlike transparent gemstones that reveal value immediately, fire opals concealed within volcanic matrix often expose only tiny hints of color at first. A narrow crack, a faint orange glow beneath dust, a small reflection visible only under direct sunlight. Everything else remains hidden. Geologists later explained that these opals formed when silica-rich water moved through volcanic rock long after eruptions ended. Over immense periods of time, microscopic structures developed capable of bending light through translucent mineral layers, creating the gemstone's signature internal fire. But the surrounding volcanic matrix never changed. It remained dark, rough, worthless-looking, which made the discovery feel even more surreal. A gemstone carrying the colors of flame hidden inside rock that appeared completely dead. And perhaps that is why finds like these remain unforgettable. Because they challenge something deeply instinctive, the assumption that beauty should announce itself clearly. Sometimes it does the opposite. Sometimes the brightest color on earth hides inside stone most people would never bother picking up. And the next gemstone discovery became even stranger, because the rough crystal hidden inside the rock was examined repeatedly by experts. before anyone realized they were holding one of the rarest gemstones ever identified. Ranked second, Painite in marble matrix, the gem nobody recognized. At first, the crystal looked like a mistake inside the rock. Small, dark reddish-brown, almost unremarkable beneath layers of pale marble matrix and mineral dust. Nothing about the specimen suggested historic rarity. In fact, early samples were so visually understated that several experts initially assumed they were examining common mineral fragments mixed accidentally into surrounding stone during geological formation. That assumption turned out to be spectacularly wrong, because hidden inside those rough, marble-hosted rocks was painite, a gemstone so rare that for decades only a handful of confirmed crystals were known to exist anywhere on Earth. And the strangest part was how easily it escaped recognition. Unlike gemstones famous for explosive color or obvious brilliance, rough painite rarely attracts immediate attention. The crystals often appear dark, uneven, and visually restrained before cutting. Some specimens resemble damaged garnet fragments or heavily stained mineral inclusions buried inside ordinary stone, which meant people saw them repeatedly, without understanding what they were looking at. That invisibility became part of the gemstone's legend. Early discoveries emerging from remote regions of Myanmar confused mineralogists because the crystal structure did not fully match known classifications at the time. Researchers reportedly re-examined certain specimens multiple times before realizing they were dealing with an entirely new and exceptionally rare mineral species. For years afterward, confirmed painite crystals remained so scarce that the gemstone developed an almost mythical reputation within collector circles. Some museums displayed tiny specimens as scientific anomalies rather than jewelry material, because obtaining another example seemed nearly impossible. Yet before identification, many samples still appeared completely ordinary. That contradiction continues to fascinate gem experts. One of the rarest gemstones on Earth, hidden inside rough stone that looked barely worth examining closely. Geologists later discovered that painite formed under an extremely unusual combination of mineral conditions involving elements rarely concentrated together in stable crystal structures. The probability of those conditions forming naturally appears so narrow that high-quality specimens remained extraordinarily limited for decades. And unlike gemstones that reveal themselves through dramatic optical effects, painite concealed its significance almost entirely through subtlety. No explosive color flashes, no glowing transparency, no immediate visual shock, just a quiet crystal hidden inside worthless-looking rock, waiting for someone knowledgeable enough to recognize it. Perhaps that is what makes the discovery so unsettling. Not that the gemstone was hidden, but that people looked directly at it and still failed to understand what they had found. Because sometimes rarity does not announce itself dramatically. Sometimes it waits silently inside ordinary stone while the world walks past without noticing. And the final discovery on this list pushed that idea further than almost any gemstone ever found. Because the rough ironstone rock hiding underground looked so ugly and worthless, nobody imagined it contained one of the most visually extraordinary opals ever revealed to light. In first place, precious opal in ironstone, the rock that changed everything. Few rocks look less valuable than ironstone. Its surface appears heavy, dark, rusted, and uneven beneath layers of hardened mineral crust. In the remote Australian outback, where many of these formations emerge from the ground, ironstone often resembles broken industrial debris more than anything connected to gemstones. Sharp edges, cracked surfaces, burnt reddish-brown coloration. Nothing about it suggests beauty. That is exactly why some of the greatest opal discoveries in history remained hidden for so long. Because buried inside certain worthless-looking ironstone rocks were flashes of color so extraordinary they barely seemed connected to the material surrounding them. At first, the signs appeared almost accidental. thin veins of electric blue running through fractures no wider than a crack in glass. Then larger sections were exposed, and suddenly entire galaxies of color erupted from inside the stone. Deep green fire shifted beside molten orange. Violet flashes moved beneath rivers of cobalt blue. Under sunlight, the patterns seemed alive, changing constantly as light traveled across microscopic silica structures hidden inside the rock. The contrast felt impossible. Outside, the stone looked dead. Inside, it contained one of the most visually complex gemstones on Earth. That discovery transformed precious opal in Ironstone matrix into something far more powerful than an ordinary gemstone. The stone became evidence that extraordinary beauty could remain completely invisible beneath rough and worthless surfaces for millions of years. And unlike polished jewelry store gems designed to look valuable immediately, rough opal-bearing ironstone gives almost no warning before the reveal begins. Collectors became obsessed with that mystery, because every fracture line carried possibility. Every dull rock might contain hidden color beneath the surface. Some miners spent years cutting through worthless-looking ironstone without finding anything remarkable at all. Then suddenly, one split exposed patterns so vivid they appeared almost cosmic, as though storms, oceans, lightning, and fire had somehow been trapped together inside stone. Geologists later explained that these opals formed when silica-rich water slowly filled microscopic cavities within ancient rock layers over immense stretches of time. As the water evaporated, tiny silica spheres aligned with extraordinary precision, creating structures capable of bending light into moving spectral color. But from the outside, none of that complexity could be seen. The rock remained rough, heavy, forgettable. And perhaps that is why discoveries like these continue to fascinate people far beyond the gemstone world itself. Because the opal hidden inside Ironstone reveals something strangely human. The most extraordinary things rarely announce themselves immediately. Sometimes they remain buried beneath pressure, time, dust, and ordinary appearances until the exact moment the surface finally breaks open. And that may be the real story hiding inside every gemstone on this list. Not simply rarity, but the uncomfortable possibility that the world still contains extraordinary things hidden inside places most people would never think to look. Some of the rarest gemstones on Earth were almost thrown away as worthless rocks, buried in volcanic ash, hidden beneath mud, locked inside cracked stone for millions of years. And the strangest part, almost none of them looked valuable at first, because nature hides its greatest creations where nobody expects to find them. And somewhere underground right now, another ordinary-looking rock may still be hiding something extraordinary.